Happy Super Bowl Sunday, students. Let's do this problem. I have a lot of questions about it, and it's a good problem. This is your first conservation of energy problem. So hopefully you looked at your book. You're going to realize, and I did go over this in one class, but I understand the other two classes are at a deficit. This is a kind of problem. We'll talk about this more later on, but this is a inelastic collision. And your book goes over this a little bit, and I'm sure you can Google it and come up with lots of results. So that's something, if this explanation's not enough, definitely seek the web and seek some help from there. But let's do this problem real quick. We're gonna do 1, 2, and 3, but we'll do them in separate videos. Okay, so we first have to extract our information. Let's do that. We have a tiger that has a mass of this. It's traveling at a velocity of this, and it has a mass of this. And our gazelle. Oh, it really doesn't say. Oh, it's a stationary. There we go. Duh. So stationary. There's 4 things, and I can extract 4 important things from this. Okay, so the first thing, the mass of my tiger equals 76 kg. All right. The other thing I can get is that before our collision, my initial velocity of my tiger. Let's actually do it a little differently. Let's go VT, velocity of tiger initial, equals 12.9 meters per second. Okay, so we've got 2 things right there. I got that in there, and I got that in there. Now I want the stationary. Well, that tells me that the velocity of my gazelle initial is going to be 0 because it's stationary. Okay. Now these are all the things that are taking place before the tiger jumps on the gazelle. So here we go. We got this. This is the lead up. And then we also know the last thing. This is supposed to be a G. Sorry, it doesn't look so much like a G. MG. Sorry. And MG is going to be 41 kg. Okay. So let's do this. Now remember, guys, conservation momentum tells us that P before anything equals P after. And this is in a closed system with no outside forces except for gravity. And that makes sense. I don't see anything. It says frictionless. So right now, so far, no outside forces. This is an ideal mechanical system. Very important to realize that. So there's no outside forces. P before equals P after. Now these all have I's on them. So they're all, you see I here and I here. They're all your initial values. So this is going to go on this side. These are all, the things we've covered so far are before the crash. So let's add them up. Momentum of our tiger initial plus momentum of our gazelle initial equals P after. We're going to worry about that later. Okay, so let's just find these 2 things. So that's the mass of our tiger times the velocity of our tiger initial plus the mass of my gazelle times the velocity of my gazelle initial equals P after. Okay, remember before equals after? And I'm just going to plug this into my calculator. It's right next to me. You won't be able to see my work, but 76 times 12.9 plus 0, basically. Okay, because it's going to be 0 times 41. And when I hit that, I get 980.4. What was he? 980.4 kg meters per second equals P after. Okay. Well, now we have to think about what's going on after. Now, these are 2 objects that stick together. When 2 objects are stuck together, tethered together, tied together, the one thing you have to realize is that their velocity is going to be the same. So my P after is going to look something like this. Now, guys, once again, this is only when stuck together. Equals the mass of my tiger times the final velocity plus the mass of my gazelle times the final velocity. Now, guys, this, and I really want to stress once again, if you haven't caught the hint, this is important, that this is VF and this is VF. These are the same. And this is only because they're stuck together. Now, what you can do is you can pull these like terms out. And you can rewrite this with like terms MT plus MG. Okay? Equals P after. But we know what P after also equals, guys. It equals this. 980.4 kg meters per second. Sorry. So now just plug in your masses here. You know your two masses and solve for VF, and that's going to be the velocity there. Okay,